All right, well, about half the people who registered are here, so I think we'll go ahead and get started. I'm Margaret Hask, I'm director of the library, and welcome on this snowy afternoon, winter afternoon in Cornwall for a talk about beautiful artwork. Everyone will be muted during Mark's talk. You know how that works because those sounds intrude and make it very difficult to continue with the presentation. But there will be time afterwards for questions. Use the chat feature, please, and I'll give the questions to Mark. And this is being recorded as well, so it will be up on the website. It takes a day or two to get it organized and up on the website, but it will be there. So I think we'll go ahead and get started. Mark and Pam moved to Cornwall over 50 years ago from the West Coast. And today he's here to talk about his work with these beautiful images, one of which is behind him. You can see it behind him there. Mark, are you ready to get started?
I am ready.
Okay, good, thank you.
Okay. Thank you, Margaret. I want to express my appreciation to the Cornwall Library for hosting the art show, and to Ann Coffin for her curatorial expertise, and Shari Goodfriend for her help in organizing the show. First, I'm going to turn into a weatherman and give you a weather report. We got about 6 to 8 inches of snow in Cornwall, but it's very light snow, so it's easy to shovel and plow. And I think it stopped. So with that, let me begin my talk and say that I'm going to start a PowerPoint here. This is the title of the show, Mutable, and this is an image from a picture in the show. When we first came to Cornwall, I was a young artist, had gotten out of college and art school, and Pam and I moved to West Cornwall, and I was trying to find my way as an artist. I had grew up with the abstract expressionists, and by the time I got out of art school, the abstract expressionism was on the way, and there were a lot of exciting new movements in the art world. Pop art, minimalism, conceptualism, color field painting, and I was trying to find my own pathway among these various movements. And I had always been fascinated by technology, by technological drawings, by engineering drawings. And I sort of hit upon this imagery as a way of finding my own pathway. I think it was somewhat related to pop art, in the sense that pop art showed artists a way to use other kinds of content, other than the traditional fine arts content. And I sort of utilized this idea to use a technological imagery in my artwork. Initially, I made a lot of drawings, and they were highly linear, and they looked a little bit like some kind of device or some kind of diagram. This is a drawing from 1973, and it's relatively small in scale, but it was typical of the work that I did in this period. I moved on about the same time to using more painterly techniques, and this is a large painting from 1973. Again, it uses a lot of linear elements. I was using drafting machines. This is made with a fairly large drafting machine and using ruling pens. I would thin down acrylic paint and use that in the ruling pens. And as you can see in this picture, there are, it definitely has a kind of technological flavor, but at this point I was becoming fascinated with computers, with the look of computers, with the look of circuit boards, motherboards, and you can see in this picture I have a little pixelated section up here, and another one next to it, and over here we have like a circuit board. And all of these elements were pure inventions. They weren't really illustrations of any real thing. They were just kind of elements of fancy and invention. So I made these large-scale paintings, and for several years I continued this work, and the paintings began to become even more diagrammatic. This is a painting from 1977, and you can see that some of these sort of circuit diagrams became much more prominent in the work and became more important. But at the same time, I had a lot of these linear elements in the work, and so it became a kind of combination of a number of different elements. This is, again, is a large painting. This is from 1978. And again, the diagrammatic qualities of the painting became even stronger. And so you see, like in this corner, we have a very strong evocation of some kind of circuitry or some kind of circuit plan. But these were combined with sort of more pictorial elements to create a total invention, a visual invention that really had no function or could not really effectively do anything. So in 1980, I made a radical shift in my work. I was intrigued by computers, and at this time, the personal computer revolution had just begun. You had the Apples and TRS-80 computers, and I bought a small Texas Instruments 99.4A computer. And I thought that this was a wonderful machine, but I did not have the faintest idea of what to do with this thing. In the back of my head, I thought I could use it for art making, but when I got it, I discovered that it really didn't do anything, and that I was going to have to learn to master this thing in some way. I knew that their artists had been making stuff with computers for about 10 years, and there was somewhat of a history and a context. But I decided that I was going to try and use the computer to make artwork. And there were programs available for computers called paint programs. They're very common programs. They're embedded in most of the computers today, and they simply emulated conventional art making. You could draw a line with a mouse or a cursor, and you could change the color of it. And they were wonderful to play with. They were a lot of fun to play with, but I decided that I didn't really think they were very interesting from an artistic standpoint. They failed to really address the qualities of the computer. So I began to learn programming, and I had no background in programming, but I discovered that programming was the sort of procedural nature of programming was very similar to a lot of artwork that had been done in the 20th century. If you think of someone like Sol LeWitt, who's an abstract artist, he had made a number of works that were essentially algorithmic, that were procedural. They were exactly the same as a computer program, only they would be executed by people instead of a machine. And I like to use the example of Jackson Pollock and the drip paintings. The drip paintings were actually a sort of algorithmic process whereby Pollock would dip his stick or paint in the brush and then randomly dribble on the canvas and repeat that many times. And this is essentially the essence of a computer program. It's a procedure or an algorithm that embodies some kind of recipe for making an image or making any number of other kinds of things. So as I learned programming, I also had the problem of trying to figure out how I was going to output this imagery. And computers, they are wonderful machines to crunch numbers and chew up numbers, but they do not inherently have any way to display the output of their computing. And it's always been necessary to have some kind of machine or device that is readable and usable by humans to see what the computer is doing. Now, initially, people used punch cards, they used impact printers, and there are also devices called pen plotters that could take the output of the computer and make a drawing. And because of my interest in drawing and the linear nature of artwork, I decided to buy a pen plotter. And a pen plotter is a very simple machine that's controlled by a computer. And all it does is draw a line. And this is an early pen plotter. It's a so-called flatbed pen plotter where the paper sits on a flat surface. And the pen, there are actually two pens here on this pen plotter, move in two axes, one along a y-axis up and down this beam, and the other, this beam moves left and right along the x-axis. And the pen plotter basically just does one thing. It moves to a point on the paper, and then the next command tells it to move to another point with the pen down. And when that happens, it draws a line, it draws a straight line. And that's basically all it does. But these devices were very fast. They could draw lines at up to 20 inches a second, much faster than a human could ever draw. So it was possible to make highly complex images with these pen plotters. And you can see in this pen plotter, this is a typical use of a pen plotter to make some kind of a technical drawing. But this was wonderful because this is the kind of stuff that I was doing. So I bought a small pen plotter and began working and writing software. And this is one of the first images that I made with the pen plotter. And it's pretty simple, pretty primitive kind of image. And there are a bunch of rectangles, and they just simply consist of a series of parallel lines, horizontal and vertical lines. And so my program I would tell the program to draw a square with a certain dimension and to space parallel lines, to draw parallel lines. And so in this case, we have maybe 10 or 12 parallel green lines I've drawn, and then we have more complex, denser squares. And you can see one of the artifacts of this process was moire patterns that came from placing two squares on top of one another that had a slightly different line spacing. So this is the kind of stuff that I first learned to do. And I was amazed at the precision and the speed of these pen plotters. So I moved on. Again, I became interested in trying to achieve a more painterly effect with my drawings. And this was an early drawing from about the same time, 1981, where I utilized an image on the screen, and I actually transferred the characters on the screen into 8x8 squares that were two different colors and had a series of parallel lines in them. So this created more of a painterly effect than the earlier drawings. So it was a process where I would make a simple image on the screen, and then I would transfer that image pixel by pixel to the paper. And I refer to this as pixel mapping. And it's an easy way to develop a more complex image from the pixels on the screen. Now, this is another drawing from about the same time, 1981, using the same process, but when I drew these lines for a single character, I added a small random increment to the drawing, to the parallel lines. So the lines took on a slightly irregular quality to them rather than the strict horizontal and vertical quality in the previous lines. And this is, I think, a good example of the power of the computer to make imagery, that you can not only make extremely orderly and complex images, but you can also add randomness to the image to create a more nuanced kind of image. These are, again, all of these pictures are drawings with colored inks on paper. Now, among the other things I discovered was that it's possible to take the power of the computer and the software to create other kinds of structures. Now, this is, I'm using the same process in the previous images, but I have converted the rectangular screen image into polar coordinates. And polar coordinates are just simply map the image onto a circular field instead of a rectangular field. And so I was amazed at the power of this process to create a different kind of image. So this image is pretty much the same as the previous two images you saw, except that they're mapped onto polar coordinates. So I continued working in this way and continued exploring. And because of the power of computer graphics, I was began to produce more complex images. And in this image, you can see that I have two images that use polar coordinates. They're mapped onto 180 degrees instead of 360. And here we have a section where I'm using just very large pixels that I've mapped from the screen. And in this case, these horizontal and vertical elements are what is called skewed, and they create a kind of illusion of a three-dimensional space. Most of my previous work had always been on flat two-dimensional images, but I found the possibility of these three-dimensional illusions so seductive that I started using them in my artwork. So this process became more complex, and I began rotating these elements in more complex ways. And you can see this is the polar coordinates, and they are repeated a number of times, and they get the elements get smaller and smaller in this case. So this is a drawing from 1984. Again, it's a plotter drawing with colored inks on paper. Now, this is a drawing from 1990 where I used some of these elements, and again, the structure becomes more complex. Again, this is polar coordinates, but instead of being flat, I have rotated these this image in sort of 3 space. So the start begins at a higher elevation than the end. And I also have added another wrinkle, literally a wrinkle, onto this, where I've mapped sine waves onto the surface of this structure. So it may sound very complex, but the sine waves are a very simple kind of trigonometric function that's just added, and that is added, repeated over and over on the surface of the image. So this is a drawing from 1990. Again, it is a drawing on paper with a pen plotter. This image is about 36 inches by 48 inches, and it was made with a different type of pen plotter where the paper moved, and as well as the pen, so that the machine was moving paper in one axis and the pen in the other axis. Anyway, it was a very fast plotter. It could create these images very, very quickly. Again, this is from about the same period, 1989. And in this case, this constructed surface that I have is part of a cylinder instead of the polar coordinates. And again, I'm using this pixel mapping technique to map elements onto these visual elements in the picture. Again, this is a large drawing, about 36 by 48 inches from 1989. I also acquired another plotter that was described as an open flatbed plotter. It looked just like the first plotter that I showed you. It was flat, but instead of having a rigid surface to hold the paper, it was open. And this allowed me to draw on essentially any flat surface that I wanted to. So I started using canvas. I stretched the canvas just like a regular stretched canvas would be, but instead it was flat on a rigid surface, and I would move this plotter around and plot sections of it. The plotter could draw about to an area of about 24 inches by 36 inches. And so in this case, this painting is about 72 inches by 72 inches. So it's fairly big. It's 6 feet by 6 feet. And so I would move the plotter around and plot one of these sections, and then literally physically pick it up and plot another section. And I was using thin acrylic inks in the plotter. And using this technique, it was possible to make fairly large pictures. This painting was from 1990. And it's essentially is identical to a regular conventional canvas, except that it was created with this technique of the pen plotter. Now, in about early 90s, I became interested in using Mylar, which is a rigid plastic substance. And in this case, it had a coating on it, a white coating. It was designed for engineering drawings. And one of the things that happened with earlier pen plotters, and the plotters had to do a lot of moving around on the paper, and they would repeat patterns over and over again that corresponded to different pixels on the screen. And in the summertime in Cornwall, it became very humid, and the paper expands and contracts with humidity quite considerably, more than you would imagine. And on some of these pen plotter drawings, the drawings would become out of register, which was very annoying. But using this plastic substance, it was possible to make, it did not absorb any moisture. It was absolutely rigid. In fact, it was used precisely for that purpose, to make very precise engineering drawings that were dimensionally stable. So I could make really complex ink drawings using this material. This is a drawing from 1992, and it's about 36 by 36 inches, and it has an incredible amount of detail. Again, this is a case where I've mapped pixels onto a surface. This is like a cylindrical surface that again has some sine waves mapped onto it. This is another image from about the same time, 1991, using the same process. So in the late 90s, after making these Mylar drawings, I became interested in using laser printers. And this is a drawing that is similar to those Mylar drawings, but it's made with a laser printer. And it was, I had a large laser printer that could make images about 11 by 17 inches. One of the things that happened as I started using the laser printer was that you had to send a complete image, a file, to the laser printer to print it. In the previous pen plotter drawings, I had used a more interactive procedure where I would draw one element and then command the machine to draw another element. So it was kind of a interactive process, but using the laser printer, it was necessary to send one final complete image to the laser printer. So I made a bunch of images using this large laser printer. And then I moved on to another process where I received a commission to make a screen. And this was made using clear plexiglass, a clear acrylic sheet, and using a laser, a high-powered laser, to etch a complex linear pattern. The laser actually cuts a furrow in the plastic, and it's kind of a milky furrow, but it was possible to make a highly complex drawing using this process. And the software is essentially exactly the same as the previous software that you saw. It was basically based on pen plotter software. And so this is a laser engraving made in 1998. Now in 2000, I made another big change in my working technique, and that was that I began using inkjet printers. Inkjet printers had been around for a while, but they had been notoriously resistant to, they had been notoriously fugitive colors. You would print out a color image on a little desktop inkjet printer and put it up in a window, and it would fade in a matter of weeks. But the companies that made printers realized that there was a market for inkjet printers that were permanent and that had permanent archival inks. part of the impetus for this was, of course, photography, which was in the process of undergoing a digital revolution, where the old method of using silver-based films and enlarging papers were giving way to digital printing technologies. And so there was a lot of interest in the manufacturers of printers to make highly permanent inks. So I bought a small inkjet printer in about 2000, and then I bought a larger one shortly thereafter. And this is one of the first images that I made with this printer. And it's a highly complex image. And in fact, it's very similar to a lot of the pen plotter drawings. The software was very similar, but it was possible to do a lot of other things with the inkjet printer. It was possible to fill areas and to vary the line width of drawings very easily with the inkjet printers. So this is an image from 2003. Again, it's about 36 inches wide and about 48 inches long. Again, this is similar to some of the earlier pieces you saw. This is a cylinder, a section of a cylinder that has a kind of a texture mapped onto it, and then, of course, the pixel mapping. Now, one of the things about inkjet printers is that they typically feed media, the paper or the canvas in a roll through the printer. And so one of the things using paper, it was possible to make images on paper that were quite long. So in this case, this is a drawing using an inkjet printer that's about 24 inches high and 72 inches wide. This is from 2005. This is another similar image from 2008. Again, it's an image on paper using an inkjet printer. This is a painting that was made on canvas. Inkjet printers can use paper or they can use canvas. And the canvas is very, very similar to a regular artist's canvas. And the image gets printed directly on the canvas. So you can see that in this case, the image is quite painterly. The linear qualities are important, but you have large areas of color. One of the things you can do with the printer using my software is that you make a polygon, like a square, a yellow square, and then you draw the outline of it, and then you fill it. And so it's just like painting, like an artist would take a brush and make a big yellow square. So this presents a lot of visual possibilities for the artist. Now, this is another image. This is from 2008. Again, this is a cylindrical structure, and you can see very easily the sort of the large pixels that have been mapped onto this surface. One of the other things that's possible to do is that you can lay down a ground of, in this case, a black square, and then plot on top of that. So this is kind of a painterly technique that's possible using the inkjet printer that would have been impossible to do with pen plotter. Again, this is an image in which two surfaces have been projected into a 3 space and plotted. First, this image was plotted, and then the next one was plotted on top of it. And in the process of doing this, the software, the imagery is always opaque. So there's a kind of layering process that goes on, and the last layer covers the earlier layers. So this is an image from 2010. This is a similar image, but again, this is plotted on a black ground. Now this is 2013, and here I've sort of reverted to flat imagery again. And I'm using this pixel mapping technique where I take the pixels on a little section of the screen and then map them onto the flat surface. And in this case, I'm using kind of a modular basis where I have like 4 large squares here, and then I'm mapping smaller squares on top of them, and then smaller squares and smaller squares, and layering them on top of each other. And they all align with the grid. So there's an element of regularity and structure to them, but there's also an element of irregularity. This is a case where I'm using more circles in the image. This is from 2017. This is a similar image. These were studies for a mural, for a large-scale mural from 2018. 2018. This is 2019. Now this is to try and sort of give you a better sense of how this is actually done and sort of demystify this whole process. This is an image of the actual code that generates these images. This is a computer language called Postscript, which is originally designed primarily for printing and evolved into the PDF format, which I'm sure you all are familiar with. But the PDF files are sort of based on Postscript files, and Postscript files were originally sort of based on almost like pen plotter commands. So this is an example of the actual code. Now, in this line, I actually set the color. Computers all use RGB colors, red, green, blue, and they need 3 numeric values to define color. And essentially, you can define any color using just these 3 numeric values. So in this case, you set a value between 0 and 1 for the R, same for the G and the B. So this command tells the printer or the computer what color I'm going to use. The next line is sets the line width, and this tells the machine how wide to make the line. And in this case, all of these dimensions are in points. It's kind of ironic that this very modern computer-based language actually uses very ancient dimensions that were used by printers. Turns out there are 72 points in an inch, and I'm sure you're all familiar with desktop publishing and printing your documents in 12-point Times Roman. So this is all points. So these points are used here to command the machine to move to a coordinate, an X and Y coordinate. And here it moves the pen to this point, and then it moves to the next point with the line down. And so it has drawn a line. The stroke command tells it to actually execute these commands and to produce a finished image. So the program runs through doing this over and over again. In this case, the line width is is decremented slightly, and we have a different set of coordinate pairs where we're drawing different lines. But this code that you see is just a very small part of one of my files. And there are there are 4 or 5 lines drawn here, but one of these images that I make is actually may have hundreds of thousands of lines or even millions of lines in it. And I also depend a lot on randomness to make these images. This is an example of a run from the program. I get an image that I like, and then I'll produce a number of examples of it. In this case, you can see 4 examples from the same program, but because you're using different random colors, we end up with totally different images in each case. So typically, I might command the program to make 100 images like this, and then I might pick out 10 images that I like, and then out of those 10, I might print 1 or 2 of them. So it's kind of a winnowing process. This is a picture of the inkjet printer that I use. It's a machine that can print 44 inches wide. There's a roll of paper or canvas in the back of the machine. The paper or canvas gets fed through the machine, comes out here, and there's a print head that moves back and forth on a track here with a series of print heads that print the different colors. So now I'm just going to give you a quick run through of the show itself. These are I think I have 12 different images in the show. These are all recent works from the last 2 years. They're all essentially COVID paintings, and they're all inkjet prints on canvas, and they are multiple images in the sense that there are prints in editions of 5. I could make as many or as few as I want, but I've chosen to make 5 images. And the show will be on until February 22nd, I believe. So if you want to see these things in the flesh, I would encourage you to come and take a look. These images are 40 inches by 40 inches. And these images are a bit smaller. They're 28 inches by 28 inches. And the image behind me on the Zoom meeting is one of those images, 28 by 28. And lastly, I was just going to say a few words about the title of the show. I called it Mutable. And I chose this for several reasons. One was it was in reference somewhat to the virus that is plaguing all of us and to the variants that we have, because it's a bit like my process of making these images. It's a question of sort of theme and variations and mutations of these images. And it's a process where I sort of incrementally change these things and make small changes, and they evolve over time. I also sort of jokingly wanted to make a comment about NFTs with this. NFTs, as some of you may know, are an expression of non-fungible tokens. And this is a kind of a new craze that has struck the art world. And one of the things that's always said about NFTs is they're absolutely immutable, which I think is rather amusing, since there are very few things that are totally immutable. NFTs have been promoted as essentially JPEGs, as computer images, and they are assigned a ownership in a kind of a ledger system, a very cumbersome ledger system based on blockchain technology. And essentially, if you buy a NFT, you own the unique rights to a JPEG image. But there are several issues about this. One is that there are always going to be totally accurate copies of a JPEG image on someone's computer, on the artist's computer. So it's unclear how unique these images are. And of course, the kind of stuff that I've been doing is, and like a lot of conventional art, is unique in the sense that artists establish, verify the originality of the image by signing it with their signature, or by the stylistic qualities of the image. So NFTs are an interesting development, and I'm not sure where it's going to go, but it has interesting possibilities. So having said that, I will turn it back to Margaret. If anyone has any questions or comments, or if I can perhaps clarify some of the things I've said. Thanks.
There were some questions and comments. Lisa suggests that these designs would be lovely on scarves, which I have to agree. They're beautiful. It'd be fun to have them in different sort of in different ways. So one question follows what you were just saying. How many copies do you typically make of an individual painting?
These are in editions of 5.
Okay. And what, yes?
Well, that's a purely arbitrary number, but I hit on 5 because it seemed like a reasonable number. If I found an image that I really liked and that was really strong, oftentimes you want to make more than one of them. So it allowed me to make a few extra copies, but not to flood the market, so to speak, with 500 or 1,000 or whatever.
Right. And what brand of inkjet printer do you use?
Right now I use Hewlett Packard. I have a Hewlett Packard Z6 and a Hewlett Packard Z3200 printer. They're very similar, and they are primarily aimed at graphic artists and photographers. They are extremely adept at producing beautiful photographs, but it turns out that they can be used to make art like mine equally well.
Let's see. So this question is, when you write the code, are you ever surprised at the image that it produces?
Yes. Generally, I have a pretty good idea of what I'm going to obtain, but I can preview all of these images on the screen of my computer. So I sort of edit them on the screen, and then when I finally get something that I like, I will then print it on paper or canvas. But indeed, what I've found that one of the things that's exciting about this is that oftentimes the image you create is totally unexpected and kind of a surprise. So that's always very exciting for an artist, to have something unexpected happen. Sometimes it's good, sometimes it's not good, but it's can be exciting and stimulating.
So Jerry asked, do you sketch out an original design, and how do you do that before you start coding for color and shapes?
Well, I don't sketch in the sense where an artist would make a sketch for a painting. My software has evolved sort of incrementally over the years. So I have a pretty good idea of what the general image is going to look like when I start a new program or modify an existing program.
And Anne asked, do you erase the program after you've printed out the paintings?
I don't. I save them. I could. Printmakers in the tradition of printmaking would take a plate and they would draw an X through it, or they would destroy it in some ways. And I suppose maybe I should do that, but I keep all of the old software. Oftentimes I'll go back to a piece of software that I used 10 years ago or 20 years ago and start modifying it again. So it's something that you reuse and recycle.
And how did you produce your mural? Was it done in segments, or how did that work?
It was done in segments, and it was printed with an inkjet printer. It was a bigger inkjet printer than mine, but it was the picture was about 60 inches by, well, maybe 70 inches by 100 inches. And it was printed in 2 sections and then essentially glued to the wall. But the printer itself was very similar to the printer that I use. And all of the large scale graphics that you see that were literally flooded with visually on buses, on billboards, on banners and hanging from buildings are mostly done with using this inkjet technology.
Where is that mural? Could we see it?
It's in Lebanon Valley College in Annville, Pennsylvania.
Let's see. Do tech companies consult artists about the uses of their technology? Is there anything collaborative going on?
So there has been in the past. I've never been involved in anything like this, but sort of early on, there was a famous show called EAT, E-A-T, Experiments in Art and Technology, where artists were paired with engineers and they created artworks. There have been collaborations like that over the years. I would say that I don't know how fruitful they have been, but they're interesting.
What about the world of 3D printing? Does that intrigue you at all?
Well, it's very interesting. 3D printers are actually very similar to pen plotters in that typically they build up layers using some kind of plastic material. And typically they will make one layer using X and Y coordinates and really a printhead that looks very much like a pen plotter. And they'll build up one layer, which is essentially a flat 2-dimensional layer. And then they proceed to add more layers to that. And then literally hundreds or thousands of layers to create a complex 3D model, a true 3-dimensional model. But the technology is, a lot of it is based on old pen plotter concepts. I have never done any 3D printings. It's intriguing, but at this point in my life, 2 dimensions are more than enough for me.
And has the reception been different in different places, the receptions to your work? So did the public respond to differently in London than, say, Berlin?
Well, when in the early days of computer art, there was initially a lot of interest in the art world, and then a kind of hesitancy settled in, and the art world wasn't very interested in computer art. In fact, they were, in many cases, they were downright hostile to it. And it turned out in the early days, a lot of the early imagery were made by people who were trained as engineers and not as artists. And so some of the imagery was not really, shall we say, not very artful. And it's taken the art world a while to become more accepting of it. And I think that today, one of the things that's happened is the use of computers in the arts is so pervasive that everyone uses a computer in some way. So that hesitancy and has vanished, I would say, or largely vanished.
Have you ever had trouble with your software going obsolete? Have you had to transfer it to a different software program?
Well, that's always a problem. I have my software has evolved 3 or 4 times as programming languages have changed, and I'm actually using pretty old software right now that I wrote 20 years ago. It has evolved and changed, but it's based on the same platform from 20 years ago.
Here's another question. Can you elaborate more about what, as an artist, led you in this direction?
Well, initially I was fascinated by the computers themselves, just by the looks of the computers and the idea of computers. And as I said, that when I actually bought one of these machines, I didn't have the faintest idea of how to go about making art. And so it was a learning process for me.
And is it completely up to the computer where in each piece the color goes, or do you have control over where the color goes when you're writing the program?
Well, most of the recent work is the color choices are completely random, and they are essentially chosen by the computer. And in my way of working, I end up with a lot of the different images that are similar, but the colors are all different. So again, it's sort of my artistic intuition that comes into play as far as picking one image over another image.
And I think this might be our last question. How long does it take you typically to write a code for a particular piece?
Well, again, it has been an incremental process. If I were to start a new program today, it would be based on an old program or an existing program. So it would be a question of making small modifications to the program. So it doesn't really take me a lot of time to make those changes.
I think that's the end of the questions. So I guess we'll wrap it up now. This was fascinating. It was very, very interesting, this collision of art and technology. It's beautiful. So I guess it's just left to thank you for sharing your time and expertise with us.
Well, thank you very much. Thank you for coming.
Everyone, please come see the show.
Great, thanks.
Okay, thank you. Bye.
Bye.